Ladies and gentlemen, I need to hear some great reply. Good afternoon. That's a very, very dull reply. Okay, I'd request all of you all to kindly rise, please stand up. You know what happens after lunch, I know. We are all into the zone. So I want all of you all to please rise. Everybody, please stand. खड़े हो जाइए. जहाँ पर भी बैठे हो खड़े हो जाइए. आपको नींद नहीं आएगा, trust me. Okay, all right. Everyone standing. I'd like you all to rotate your hands, please. Rotate your hands. Just rotate your hands. All right, and rotate your waist. जरा कमर हिलाइएगा. All right, and when I say sit, you will stand, and when I say stand, you will sit. You will have to do the opposite. All right, are we clear? Everybody sit. Very smart. No, हाँ sir, आप बैठ गए ना, वापस उठ गए. Everybody sit. All right, everybody stand. Everybody sit. Everybody stand. Everybody stand. There are some of them standing. Everybody stand. Come on, stand. Okay, everybody sit. Rotate your hands, everyone. Look at your partners and give a nice smile. And a round of applause for yourselves. Come on, everybody, a round of applause for yourselves. Well, you all can sit. Sit for real. Yes, sit for real. Well, ladies and gentlemen, our next speaker is going to talk about AI-rich chatbots. A little bit about his profile, ladies and gentlemen. He is a co-founder and CEO of the company Haptik, which is on the screen. Haptik. Oh, it's not there. Haptik. He founded Haptik in the year 2013, way before chatbots were cool. In April 2016, Times Internet led a Series B investment into the company. In 2013, he also co-founded and was the lead investor for Flat.to, Flat Chat, a real estate marketplace for college students. Flat.to was sold to commonfloat.com in April 2014, through which he fully exited the company. Ladies and gentlemen, the co-founder and CEO. Can we put our hands together for Aakrit Vaish? A round of applause, ladies and gentlemen, for Aakrit Vaish, the co-founder of Haptik.
Good afternoon, everybody. I have the really hard task of trying to keep everybody awake after the lunch session. I was really trying my best to get out of this session and do it a little later, but then there was no option given I already asked for 3-4 different reschedules. But thank you so much for having me over here, Dr. Gupta and the rest of the team at the Computer Society of India. It's always fun to be at IIT Bombay. We are one of the few, actually not few, we're probably the only AI company that is based out of Mumbai. So we feel very proud to evangelize and just overall promote the Mumbai tech ecosystem, and IIT being the hub of it. So what I'm going to talk about is a little bit about what we do, and then also the space of chatbots and how we see the world when we talk about what chatbots are. So very quickly, he already given a background about me. So I co-founded the company about 4 years back. Today where we are is that we are actually one of the world's largest chatbot platforms now. Obviously Facebook does a lot of work in the chatbot space. Google is now doing a lot of work, but outside of some of the big guys, by our calculation in terms of the number of users that we reach and in terms of the number of bots that we have, we are among the top 5 largest companies in the world. We reach about 10 million users monthly who use our chatbots. And a total of about 5 million monthly chatbot actual chats and requests. We've done everything over actually India only. So even, just in this entire volume of business that you see is all driven through India only right now, not any other market. And because we've been at it for a while and the way we've gone about it, we're kind of an end-to-end full stack chatbot company. So if you look at the, and I'll go into this a little bit, but typically, chatbot companies, there are certain people who build the tools, there are certain people who then build the actual consumer-facing apps, There are certain people who build the underlying technology of natural language processing. We actually all do end-to-end. So we have our own natural language processing, we have our own tools, we have our own direct apps, and we have the entire stack has been pretty much built in-house. So before, again, walking back into just some of the work that Haptik is doing, and specifically the topic of this session, which is AI-rich chatbots, the first question is, what is a chatbot, right? I think there are some ideas that people have about it. We are ourselves trying to figure it out as we go kind of, year by year and month on month. But broadly, the reason why there is so much excitement or belief in this category or in this space is because of this sort of graph. This was something that actually Microsoft, Facebook, Google, they all put out, let's say last year or the year before, which is that in terms of the transition of interfaces, right? So let's say you moved from when you had browsers or the desktop, which was, let's say, a browser window would open up. It was probably a 14, 15-inch screen. You would click on a bunch of things and you would search and get something done. That transitioned onto the smartphone, where you then had, let's say, a 4-inch screen, and then you had apps, which then would be a lot more native, and they would be able to accomplish a lot more than, let's say, what browsers and search were able to. Similarly, the next transition of this is now going to be that there will be no concept of apps left anymore. There will be no concept of browsers left anymore. There will be simply messaging applications everywhere, right? So whether it is a WhatsApp that we use all the time, whether it is the SMS app, whether it is Facebook Messenger that's used in the US fairly heavily, or let's say some of the work that Amazon is doing with Alexa, Google Home. It's basically all going to be messaging interfaces everywhere around us, and bots are going to be omnipresent, and bots are going to be the applications to get things done on these interfaces, right? So instead of going to a store, downloading an app, you'll have every service that you need within a messaging interface around you, which will accomplish your goal. So that's really the excitement. You'll hear this term of paradigm shift being quoted a lot by anybody who talks about chat interfaces or chatbots, and that's really the big bet behind why there is so much excitement and investment behind this space. And he's the biggest proponent, by the way. Every talk of Satya Nadella, every interview, he's one of those big believers that this is exactly what will happen. And this is one particular quote of his that I like the most, which is that anybody who is building any applications, whether it's a mobile app or a website or anything else, right, will build bots as the new interface, where a human dialogue interface will be a lot better than the menus of the past, right? So your menus and buttons, they will go away by simply saying that, okay, look, there is a dialogue happening, which, let's say, an automatic bot, or in the olden days what you call a robot, is actually processing. So what's happened over the last, so this entire era or area of chatbots first exploded roughly, I would say, 2014. I mean, actually, just going back a little bit in history, because it's that kind of an event, bots or chatbots have been around, for pretty much like 30, 40 years, right, in some shape or form. Whether it is, it used to be there used to be the computer that you could talk to who would answer back in simple things. There used to be, more lately in the late 2000s, things like Siri. So broadly, the concept of, hey, I should be able to talk to somebody or send a message and a robot should reply back, we all have wanted that for years and years. There has been a lot of reference in movies about it, right? So there's obviously the most famous one, which is Jarvis in Iron Man. Then there is, a movie called Her, which is all about how a robot assistant actually completes every single task. So this whole concept has been around for a while. It started really becoming real, like I said, about 3 or 4 years back. What we've tried to focus on is that, okay, look, let's narrow it down a little bit and think about what are the areas, or what are, let's say, specific types of categories or use cases which a chatbot can do really, really well, right? So whereas you can take the entire spectrum and you can say a chatbot should replace Google, right? We're saying that, okay, look, let's step back and look at few categories which we know that either by data or by actual applications out there have proven out well, and chatbots are actually doing well. And for us, these are broadly sort of the 5 categories. Again, they're very high level, but at least these are 5 categories where we've said that, look, this is areas where a chatbot can actually do well, right? Where a chatbot can do a lot better than, let's say, what a mobile app could, or, you know, what, let's say, an internet browser could. So one of them is this whole virtual assistant space. So this virtual assistant, I refer more to, like, you know, set a reminder, find something nearby, very like day-to-day mundane tasks. There's e-commerce. In e-commerce also, not really very complex tasks of, let's say, buying a furniture, but let's say buying electronics, buying flights, buying trains. These things are things that a chatbot can do really, really well. Obviously, customer support, which is something that, you know, is the most popular demand, mostly from enterprise at least, which is, can you automate our customer support using a chatbot, whether it can sit on their website, inside the mobile app. Lead generation. So interestingly, this is one area which is really picking up, particularly this year, which is that, you know, typically if anybody, any enterprise or any brand or any company, right, if you want users to come to your website, fill a form out for anything, we are seeing these forms being replaced by bots now. Where bots, which is going one after the other, the conversion of that form filling is significantly higher than the traditional form. So we are seeing conversion rates of almost like 10 times. So let's say typically if a user lands on a web page and he presents a form, the 1 to 2% is the number of people who end up finishing a form. We are seeing bots do about 10 to 12%. In that conversion, simply because it's a lot easier to kind of have that back and forth. Utilities again sort of very broad, so I'll park that for a second, but it's essentially again anything to do with this whole like calendaring space. So one of my favorite chatbot applications actually is an application called X.AI. X.AI is a San Francisco based company. What they do is that, let's say, you know, you sign up for the service, and then it actually acts as your scheduling assistant on email. So what will happen is that, let's say I'll send an email to Dr. Gupta saying, hey, looking forward to meeting you. He'll reply back, great, when and what time should I meet? You know, I'll reply back saying, copying an email address, x@ai.com, saying that here is my assistant who'll schedule the meeting for you. And then actually the bot takes over on email. So the bot replies back, and her name is Amy. That bot's name is Amy. So she will reply back saying, hi Dr. Gupta, this is Amy, I'm Aakrit's assistant. You know, he's available on these dates, what time works for you? And a full conversation actually happens, right? I would highly recommend everybody to check it out, if for nothing else, but just a lot of fun. And especially it's a lot of fun when people who are on the other side who don't know it's a robot, and then you meet you and be like, oh, your Amy assistant is very efficient. You know, it's so that kind of utility calendaring stuff is also working out fairly well. Question. So again, this is something that I ask myself very often, and I try and almost play devil's advocate by asking myself the question almost like multiple times a week, is that why do chatbots work and why should they work, right? Why is there so much noise around it, besides of course messaging being everywhere? What are the key things that actually make it work? So first one, like we said, right, that messaging is the most natural and popular interface for the 21st century smartphone. I did some math a few weeks back where it was that we spend the maximum amount of time today doing messaging. And that's not saying that maximum time outside of sleeping. Actually, and actually that's also debatable in some age groups. I think they do more messaging than sleep also, but that's debatable. But outside of sleeping, if you combine the number of minutes spent in a day, you spend highest number of minutes inside a messaging app. Combine WhatsApp, combine SMS, combine, you know, Twitter's a little bit of direct messaging. You combine all these different platforms, right? So it's really not necessarily the most, you know, a UI only for the smartphone. It's like our life UI. Like we spend more time doing that than anything else. The second is that, you know, a lot of simple things, right? So lead generation, like I mentioned, a good example. A lot of simple things should not require websites or apps, right? Simple tasks, you know, which should just be done by sending a message, responding back and getting it done. It should not require me to build a complicated UI, menu buttons, go in, click, do this, do that, right? So a lot of simple things, and we are seeing that, in a very funny way, you would think that AI and chatbots and all of these are technologies which should, change our world, do very, very complex tasks. Ironically, what's happening is that they're actually doing the simplest tasks the best. And they're taking away the headache of building, complicated apps and websites for simple things. So I'll give you an example. We're working with a Path Lab company where, their largest request on the call center side is, what is the status of my report? So people go into the actual centers, they get their blood tests or other tests done, and they're waiting for the report. And 80% of their phone calls, right, basically on call, when people call their call centers, where is my report? Now that's something that, you should not need to call, one. Second, people feel very lazy to go on a website, web page will load, time lega, then I have to put my number in, I have to hit submit, it will again load, it will give me so much information on one page, here is the status of your report, this is where it's going to happen. People don't want all that, right? People simply want, where is my report, tell me in 3 words, boom, right? And that's the kind of chatbot application we're working for them, and we're already seeing tremendous success and reduction in actually call center calls that they are getting for this query itself. So things like those, like simple things, are things which we believe our chatbots can be amazing at, and there should be no need to have websites or apps. The third is the personalized conversations, right? So and again, this is again the belief in the space, which is that everyone will prefer using a bot if it actually works versus going to a website, because it's just fun, it's easy, it's like personalized, you're actually chatting, you don't feel like you're seeing a bunch of ads or bunch of screens that are too complicated, right? So the personalized conversation element adds a lot of value when we're talking about a chatbot. The fourth one, right, which is that because chat as an interface is so natural to the phone, it basically can fit in anywhere, which means that any app or website that enables a chat window, it feels like it's very non-intrusive, it's very natural, it's like an additional sort of feature that you're providing to the end user. So in that sense, very non-intrusive and very customizable. So the advantage of again a bot is, today you build an app or a website, you want to change, let's say, a few buttons and a few screens, it'll have to go through a dev cycle, release cycle, you have to figure out a UI, you'll have to talk to everybody in your team to get them on board. Versus a bot, you want to change what the bot says, it's like 2 minutes work, right? You want to change, let's say, the way the bot behaves, you want to change the personality, half an hour. So this is what bots make it very customizable on the go to change things, versus the other interfaces. And the biggest one for me is that, for anybody who works in the mobile app business or has done anything with mobile apps, you will know that, the one thing that is oil for you is push notifications, right? Everybody craves to do push notifications, and people who use apps, you must see that you must be receiving so many notifications, you must be frustrated and turning a notification only off, right? So the push I remember actually one of my friends who was the founder of one of the largest e-commerce companies that sold, he had this best quote once upon a time where notification is the new opium, right? Where it is actually the new, it's the next thing where you're addicted in, where you're basically just spending your time in a notification center. And especially for people who work in the business, right, you want to capture as much of the notification area as you can. Now what happens with some push notifications is they come off as spammy, they come off as mass, you slide over them and remove them, you don't want to look at them again, you want to delete the app that sent you the notification, right? With a chatbot, because it's like you're having a chat, even if half an hour or 1 hour later if the bot sends a message saying, hey, by the way, have you checked this service out? It actually works significantly better. Right, so we've actually seen that bot-based notifications have a conversion rate of again some 10 to 12 times versus simple notifications. So because it's in the chat environment, because it feels like you're having a personalized conversation, these things work a lot better. How much time do I have? Sorry, how much time? Very well. Because we started late, right? So how much time do we have? 5 minutes, I think. Okay. Cool. So very quickly about Haptik, and I'll walk into a couple of examples before we'll stop for questions. So I think I already walked over that. We build chatbots across the spectrum. A About our technology, the entire stack is built in-house. This is the best way to think about it. We build bots across different things, so we can build a bot for you on Android or on iOS, on the website, on mobile web, Facebook Messenger. We're now doing some work on Twitter as well, but not many people use Twitter. So we're trying to see what to do. There's a machine learning engine underlying, which is essentially the entire parser that looks at the messages coming in, makes sense of them and responds back. Very quickly getting into a little bit of technical detail, the underlying tech used is all around the lines of entity recognition. So there are multiple ways in which you could build a bot or understand language. But the most proven out way is entity detection, which is, let's say, how Google does it. So the way it works is, let's say you send a message saying, I want to book an appointment to go to a doctor. What our engine tries to do is tries to detect keywords, right? So we try and detect that, okay, look, I've seen appointment and I've seen doctor, right? Based on this, let me send a response based on that understanding. So we detect entities, and we build our own entity recognition algorithm, which actually is one of the first for specifically the chatbot industry globally. And then there's a bot management platform where we have, we have tools where you can build a bot. We actually also have a combination of, so one of the things is that, chatbots, while they're getting there, right, obviously, people will send messages that the bot will not understand, right? That's by design, because humans, we are like that, where we like to send whatever message we want, and that's the whole purpose of a bot. So what we also have is, we have a hybrid approach where we have humans also intervene. So we have a fairly large sort of support center that intervenes, whenever the chatbot is almost on the verge of screwing up, we come in and make sure that, okay, look, things are sorted out. So we built a hybrid approach where the routing from when the bot is not able to understand something and passes it on to a human is very seamless, and something that you can't tell. I'm just going to quickly walk past this. Okay. So very quickly, the way specifically we build, again back to the topic of the conversation, is AI-rich chatbots. So for us, the goal is that build a number of different applications that can apply to various different businesses. So one way in which we do is that we have an underlying assistant service, which also has a direct-to-consumer app called Haptik. So Haptik app is also an app of its own that you can access through iOS and Google Play, where we aggregate a large number of typically e-commerce services. So we aggregate flight bookings, cab bookings, train bookings, recharge, bill payments, local deals, and other things. And what we do with this is we also package this and we place them in other apps as well. So the way to think about it is that for a lot of other apps, large publishers or large apps that they have, they want to create an engaging layer or an engagement layer in their applications. So they take our solution and they put it inside their application such that they instantly enable an assistant service within their apps. Examples of that being on the extreme left, this is not completely live yet, so please don't start opening the TOI app right now. In about 10 days, it will be completely live. But the TOI app is going to have a personal assistant service powered by Haptik. So essentially, you can see the little banner over there that says Times Personal Assistant. If you tap on that, it will take you to a screen that has all the different services that I spoke about. People can go in, complete tasks, and get it done. For anybody who has a Samsung My Galaxy phone, you can try it out right now. The Samsung My Galaxy phone has an app called My Galaxy, which is Samsung's own app, which is loaded on every device. My Galaxy has an assistant at the bottom, front and center, that is powered again by us. That's live across all their 10 million odd devices. So you should, if like I said, anybody who has any range of My Galaxy phone from low to high end can check it out right now. And then there's about 4 or 5 other such partnerships also in different stages, but that's one model where we work with large partners, large publishers, mostly OEMs, news, or large utility apps to basically build an assistant layer inside their product. One of the things that we are doing a lot of work on is, so I mentioned to you this whole lead gen bit, where lead gen is proving out to be so much better on a bot versus a form. So we're also building out a lot of bots that principally do advertisement, right? So the way it works is, within different contexts, right? Instead of showing a banner ad or instead of showing, a pop-up ad or a roadblock ad, what if a bot could tell you, or what if you could show a chat ad, which is, hey, look, why don't you check this product out by HDFC Bank? And what we do for this is we basically place them across our network. So our network being, the Samsung app or the TOI app or other apps, as well as our clients can take these solutions and then work on other places where they also want to use this as an ad unit. So instead of using this, click to call, click to action being like a website or an app, they can use the bot to actually, complete the lead generation or form filling. And finally, of course, the enterprise use case where we mostly do build bots for customer service, automating customer service for large organizations, either on their website or on their mobile apps or on their Facebook Messenger. Like I said, the most successful ones over here are ones that are fairly straightforward and simple in demand, where the highest volume of queries, which is 70 to 80% of the queries, get completed through simple things that users can speak. So across the board, our partners and clients, I mentioned Samsung, TOI, we do a lot of work in BFSI, HDFC Life, Sher Khan, Edelweiss. We are now in the process of building out a pretty cool bot for Tata Docomo. We work very closely with Uber, Ola on some of the bots that we build for them. So across the board. Right now, I think one of our biggest challenges as a company and for me as running this company is I think we're spread too thin between the different verticals that we have clients in. So one of the things that is our goal over the next year is kind of narrow it down and focus on key verticals, because right now this looks like you're spread across the board. There's Coke in the middle who we build a bot for. By the way, you should check that one out. Go to facebook.com, Coca-Cola India, and if you start chatting with the Coca-Cola Messenger, that bot again is powered by Haptik. That's a pretty good one, because you would think, what are you going to chat with a brand like Coca-Cola about? But it's actually a very interesting bot that we built for them. Very quickly, because we are IIT Bombay, I put this slide in, specifically talking about, our first member of the team outside of the two founders was Professor Dan Roth. We actually believe that a lot of the work that you have to do in sort of, particularly as startups and companies who are by design have less resources, will come from academia, will come from research, will come from things that they're able to help us with. So we actually, Professor Dan Roth is now a professor of natural language processing at the University of Pennsylvania in the US. He's done 20 years of his work pretty much in this area, and we work very closely with him on a lot of things across our algorithms. And then we're funded by Times Internet, which is the digital arm of the BCCL group. Thank you. And then finally, just this one last thing that I want to leave us with is that what we've learned in this entire space, especially to do with bots and AI-rich bots, as we like to talk about, is that it's as much a design problem as it's a machine learning problem, which is that it's as much figuring out which particular things you want to automate, how you want to automate them, what tone should the bot have, what character should the bot have, how should the bot talk, should it be rude, should it be happy, should it be sad, should it be formal, should it be friendly, right? Those things go hand in hand in making a chatbot successful as much as the underlying technology. Thank you so much. Any questions? Okay.
Do we have questions? We have room for only 2 questions. There, can we have the mic to that gentleman out there? There, right there. So your name and the question.
Yeah. I'm Milind Karnar from Shanankar Kutch Engineering College. I have a question that how safe it is to pay with Haptik, means bills and all. How safe it is to use the chatbots for this service?
Yeah, so basically it's as safe or unsafe as doing bills on any other app. The way it works is that, so I think the clarification, and if I understand the question correctly, is, so we don't collect payment details inside chat, right? So payment for whenever, let's say, it comes to the point where the bot tells you, look, your bill is 730 rupees, pay now. When you tap on the pay now, you're then taken to a secure payment gateway. So you actually don't actually give credit card details on the chat. That would be dangerous, yeah.
Thank you, sir.
All right, can we have a mic here?
I have a
This
question.
gentleman? Yeah, so one sec. So your name and the question.
Yeah, my name is Prashant. So the question I have is specifically using this bots as virtual assistants. So you showed one of the areas where you use bots for as a virtual assistant. So is there a way this can reach out to it can be multi-language and wherein people who cannot message in English or across languages, and also what if people do not know how to operate a smartphone? They may use any other operating system, or they may use this bot service more as a kind of a help assistant, multi-language across, so that it can reach out to rural areas, etc.
So, great question. Something that is top of mind and agenda for a company like ours as well as a lot of companies. So, the biggest example of a local language chatbot service that is going to be launched is the JioPhone. Right, so the JioPhone, if you have seen or read about it or seen the Reliance EGM that they had, where they were talking into the phone and responding back, right? Now, if you think about the JioPhone, target market is also the 500 million rural India, right? So for them, they've been working on a localized language voice assistant chatbot. Right, where essentially on JioPhone you could speak in Hindi and say, mera bill kidhar hai, and then the voice assistant reply back to you in Hindi and actually get taken care of the entire request. So they are working on it. From what I know, that they're seeing some reasonable success, but it's going to take a long time. That actually is a very complex technology problem. So we've built out a Hindi language chatbot before. Did not work too well, so we stopped it because we realized there's a lot more research that needs to go into it. That's one example. The second one is that I'm not sure how many people have followed the news last week. Amazon launched Alexa, or rather Amazon Echo in India, for India only. That starts shipping next week, and the first version is going to be English only, but they're launching the localized Alexa version by December. So companies like ours, who obviously have significantly finite resources compared to them, we are looking at them to see what kind of innovation they are making in the space, because according to us, it requires years and millions of dollars of research to figure out that problem. But absolutely, for us as well, beyond the 15, 20, 30 million users, we will have to look into language starting next year.
All right, do we have?
I just have a quick question. How do we compare your engine vis-a-vis the Microsoft, Louis and or the Blue Mix?
Yeah, great question. So Microsoft has their own bot framework. Amazon has Lex, which is their own chatbot framework. And Facebook doesn't have anything. Google has API.ai, which is the company that they bought. In terms of, can you build a better bot using theirs or ours? That's subjective. I think that doesn't matter, right? You can build a great bot using any one of these tools. I think the question is that the way these companies are doing it is they are giving it as a free tool for you to use and you to build and make a bot, right? What we are doing is kind of the very reverse, where we are saying that we will actually handhold you during the bot building process, and we'll work with you kind of to figure the entire process out. So for us, we can't compete, and we don't want to compete with them, because their goal is to get 30,000 developers to use their tools and build a bot. Our goal is to get 50 large enterprises who we can work with very closely to build the bot platform out. And to specifically answer in terms of technology, we think we're as good as the other platforms as well. But I think there's still a lot more work that all of us need to do.
All right, thank you so much.
Thank you guys, thank you.
Thank you so much. Ladies and gentlemen, a round of applause for Mr. Aakrit Vaish. I'd like to call on a stage I'd like to call on stage Mr. Ajit Joshi, Secretary CSI Mumbai chapter, to please join in. Ladies and gentlemen, can we please put our hands together for Mr. Ajit Joshi? That's a token of appreciation to you, Mr. Aakrit. Ladies and gentlemen, a round of applause. Thank you. Thank you so much. With that, we come to an end of AI-rich chatbots, and we move on to our next the next topic, that is hardware loop simulation for multiple vehicles. And ladies and gentlemen, to give and throw some light on the same, we have someone who is a PhD thesis, trigonometric shear deformation theories for plates, postdoctoral fellow at the University of Delaware, September 1997, research associate, Aerospace Engineering Department from the very own IIT Bombay, and he is also a research scientist of the IIT Bombay. Ladies and gentlemen, it gives me immense pleasure to call on stage Professor Hemendra Arya, Department of Aerospace Engineering, IIT Bombay. Can we please put our hands together for Professor Hemendra Arya?
Good afternoon to all of you. So, I'm Hemendra Arya, and this work is from my student Swarupangal. He's here actually. So, any questions that comes, I think he'll be the better person to answer. Of course, this topic is not directly related to computer science, but this is basically works on very hardcore principles of the computer science. I'll try to justify how it gets related to computer science, okay? But let's first bring me the motivation for multi-agent systems, and then we'll look at hardware loop simulation. Okay? So today, if you look at scenarios, till a few years back or maybe decade ago, we are only flying big vehicles, big aerial vehicles, but today, world is filled with small drones, and people are looking at flying them in groups. And if you fly them in the group, they cannot carry all the payload, so the payload also get distributed. So the task is getting distributed, and collectively they are supposed to complete some mission. And when they collectively they're supposed to do some mission, means they are supposed to interact with each other, and also they have to interact with the ground station. So that's the motivation about the multi-agent systems. And this is just not applicable to aerial vehicle. You can think about any robotic application also. So let me give some more practical examples. Like let's say this is the boundary of the IIT Bombay, and we want to monitor its periphery using small aerial vehicle. But since the boundary is large, so one vehicle may not be able to give you the complete information. You may need multiple vehicles which are flying at equidistance with each other and following this boundary. We have a lot of festivals in the country. This picture is given of a Kumbh Mela, which is spread over few square kilometers. And if you want to monitor it, one aerial vehicle is not sufficient. You have to fly multiple aerial vehicles to monitor this and give feed to the security people who are monitoring in real time such systems. Okay. So now let me get to what actually we need in this aerial vehicle to make it fly the way we want. So of course the first is the flying vehicle which is required, and then we need some onboard intelligence which will help us in doing it without human intervention. Okay? Because we want to reduce the human load in flying the vehicle, we want to have more human intervention in looking at the data which is coming from the camera or whatever sensors you have mounted. So we need an onboard computer, and this onboard computer will sense the states of the aircraft, which is in terms of the angular rate, acceleration, another quantity called altitude, attitude, airspeed, and uses this information and finds out what next to do. So that command is given to the actuator, and that's how the flight happens, and we go from one point to another point. Okay. So now comes, I'm just going to go to brief idea about the simulation, and that's how I'm going to build up the story for the hardware and loop simulation. Okay. So now when we, in the previous picture where I have shown you this aircraft, okay, and the idea is if I build a complex system, like I want to fly 16 aircraft together, let me pose this scenario. And of course this vehicle is small, I can go to the field and test individually. But as soon as my complexity increases, going directly to the field and testing becomes a major task. So is there a way I can test it first in the lab or in my in any factory, and when I go to the field, I have a very high chance of success. That's the idea of this hardware loop simulator, okay? Now, as I said, if I'm testing in the lab, I'm not flying the vehicle. Lab space may be 100 by 100 square feet, not more than that. So to simulate that flight in the lab, I have to solve equations which are related to flight mechanics, okay? And typically these flight mechanics equations are posed in the form of ordinary differential equations. So we use some numerical method to solve these ordinary differential equations. And those simulation could be in C, Fortran, Python, MATLAB. There are many combinations, many ways we can solve this simulation, and combination of these can also be done. But when we look at this simulation, when we do typically, let's say in a MATLAB or a C code if you're written, and if you do a flight mechanics simulation, let's say your flight duration is maybe 1 hour. And when you conduct the simulation, the whole 1 hour flight gets over in maybe 2 minutes or 3 minutes, because the execution is much faster than the real flight what we have. That is basically the computational power is very, very powerful actually today. So now, if I want to test my hardware, then I cannot test it with this framework, okay? That's the issue what we have, okay? So now, what I said earlier, we have vehicle which is in the motion simulator, which gives the sensor simulation. Sensor output is given to my navigation guidance algorithm, and then the actuator output, and that's how the feedback gets closed actually, okay? And this is what running in my autopilot board, which a small 32-bit ARM processor or maybe 8-bit microcontroller, okay? Okay, just let me introduce a few terms which will make more justification for the hardware loop simulation. So typically in engineering simulation, we have, first we call it modeling simulation. So where everything is in a model, and which means described in some mathematical equations. We connect them the way earlier I showed you the block diagram in that serial form and execute the that simulation framework, okay? And I get my output versus input relationship. So the next task is, as I said, I have my actual system, I have an onboard computer. Now the onboard computer programming may be different than what I do it on a normal PC, which could be a C programming or a MATLAB based. So if I have some way to convert that algorithm into the language and the code which will actually get ported on the onboard computer, and if I do the simulation, then this is called as a software in loop simulation, okay? Still we are working only in the software domain. There is no hardware has come into the picture. So if you are working in the software domain, there is a big advantage, as I said earlier, that 1 hour flight gets executed in 2-3 minutes. So if I want to do 1,000 simulations, or for 1,000 hour simulation, I don't need 1,000 hour of time. I need maybe 100 hour of time to complete those 1,000 hour of simulation, okay? So that's where the software in loop simulation, software in loop or software simulation or model in loop simulation becomes very, very important. But how are we sure that the model in loop simulation what we are doing is going to match with the reality? If that is not matching, then the whole job of doing those 1,000 hour simulation is not fulfilling the purpose. So the next part comes where actually we can have the processor in the loop. The processor in the loop means the same onboard computer, which is 32-bit computer or 8-bit or what, or 64-bit computer. You bring it as a part of the simulation framework, okay? Now the issue comes that processor which I have brought it as a part of the simulation is going to work in the real time. It's not going to work faster the way computer was working faster, okay? So now I have to match rest of the simulation which can work with the same time scale of the processor in the loop, okay? That's where this hardware loop simulation comes. So there's additional part with processor loop. So as I mentioned earlier, the aircraft is, the processor is computing my actuator commands, and then it is given to the actuators. Then actuator actually move the control surfaces. Control surfaces in terms of elevator, aileron, rudder, or in a very simplistic term, if you are driving a car, when you move a steering, it moves the wheels actually, okay? So that's the actuation you are given by hand, but if you are a power steering, then someone else is giving actuation based on your steering turn what you are given. So that's the actuation, what I mean in the terms of the aircraft. Okay. So now, as I said earlier, we want to create a system so that I have very high confidence when I go to the field. It means I must have very high realism in the lab itself before I go to the field. Okay. So this is what happens. This model in loop and software in loop simulations are virtual. There is no real hardware coming into the picture. But when I count the PIL hill and finally the real, these are the real hardware. So as I move along this, my realism is increasing into the simulation. Okay. But at the same time, when I look at the complexity, cost, effort, this actually increases exponentially, though I have shown it like looking like a linear one. So as I said earlier, here my simulation time is 1/10 or maybe 1/50th. But here when I move, my simulation time will be same as real time. It cannot be different because the processor which is in the loop is a real, or hardware which is also is in the real. So let me just quickly give you a few ideas which I'm sure many of you are familiar. Real-time system means it takes action as and when required. The action could be in acquiring data, sending data, commands to external world, but it's different than the multi-user and multitasking. Like we use multi-user system which are multitasking system, like Unix, or multitasking is our Windows system, but those are not real-time system. They only give a feel that it is a real-time system because the response time is so slow and that we are not able to get the feel that there is a delay in that. Okay. And like here example given for the real-time system, a telephone exchange emergency system. And real-time system is a simulation environment in which input and output happens with a wall clock. The wall clock is like there's a clock here and that's common for everybody. With that time is followed by everybody. If 1 second is for this clock, it means the 1 second for rest of all the system which is in the simulation. Now let me just give you one idea about the hard real time and soft real time, which also you must be familiar with this. So hard real time, we can think about, let's say you have an onboard computer which is used for in automobile for firing ignitions. Okay. Now just imagine one of the firing doesn't happen at right time. Firing, when I'm saying, means the spark plug is not ignited at the right time. And if it's not ignited at the right time, it will have a very heavy penalty on the power output what we are getting. It will have a heavy penalty on the emissions what we have. So now what's the responsibility of the onboard computer? It has to ensure that that event happens when it is required. Okay, and that's a demand from hard real-time system. And that can only happen if you give all the resources which is required for that event. So now the underlying principle that whatever OS or code you write, you make sure that all the resources are available when it is required. The another idea which is related to soft real time, which says if deadline passes, still it has some utility. Okay. So like here example given is if you are watching a movie and let's say it is 25 frames per second, once in a while one frame is not shown to you. So it only becoming like 1/25 seconds is that image is not shown to you. But our eyes are better than 1/16 is, it's okay. So that frame which is missed, actually we have not realized it, but it's a lot more stringent condition on the execution of that particular software. Okay. So if you have so I'll explain you in some ideas how do we use this hard real time and soft real time with respect to our flight mechanics experiment. Okay. So now some more about flight simulation. So as I mentioned earlier, like this is my real hardware which is in the loop, and this will work in the real time. When I say real time, it's working at the wall clock time, whatever the processor it is. And rest of this motion of the aircraft, which is actually I'm conducting the lab, so aircraft is not flying. So I have to create this motion of the simulator or motion of the aircraft which matches with this time or real time of the processor. But also same time, this processor what I have, they use variety of sensors. Sensor could be analog, could be digital. When I say digital, the interface could be RS-232 or maybe I2C. And if it's analog, then the interface is ADC kind of thing. But here computation, what I'm doing, this is happening in maybe a 64-bit computer or maybe 32-bit computer, okay? And that gives me numbers which are in floating point. Now I need to convert these numbers which are coming from motion simulator, which can go as a correct signal input to the autopilot board, okay? So if there is an analog sensor here, I need an interface which is in the form of the DAC. So DAC will take the numerical numbers input and give an analog voltage as output. If there is a digital interface, let's say RS-232, then I need an interface which will take these numbers which is computed from here, convert into a RS-232 sentence and send it out to the onboard computer. Now what is the beauty of this? The onboard computer will, as a system, will never able to realize that it's in the actual flight or in the lab, because we have created a synthetic environment around it which is same as what we'll have in the real flight, okay? And this is what we call it as a hardware loop simulator or processor in loop simulator. Now, as I said here, this is a simulation which has to run in the real time, and that's where the computer science has played the role, creating a real-time operating systems, okay? But today, operating systems and computers themselves have become very fast. So slowly, the requirement of real-time OS is reducing. I'll give an example. We are using a general purpose OS and is still able to maintain a kind of a jitter in the real-time operation. Okay, I'll just give you an idea about that. Okay, so let me just give you a brief idea about how the equations are solved. So let's say these thin lines are some kind of a time step which is used in propagating or solving ordinary differential equations numerically, okay? So every time when I solve my ordinary differential equation here, it gives me the output which is meant for this time step, okay? So I'm starting execution here, but the output what I'll get is meant for next step. Now the computers have become so fast that my execution actually gets in this thick line. Like in today's computer, which is 2 gigahertz or 3 gigahertz, 2.7 gigahertz if you take it, 1 millisecond is my step size here, and it takes only 70 microseconds to compute the simulation states, okay? So it means the states or the aircraft position, velocity, altitude, whatever, which is meant at this, actually available right here. So rest of the time, my system has to sleep because I have to work with the wall clock time. So the state which is available here, which will be actually given as the output at this point. Okay, so rest of the time I'm just sleeping, or I should have a mechanism for sleeping. That's how I'll put it. So yeah, so if there is a RTOS, then typically we don't worry because RTOS will have a scheduler. So the scheduler will keep on calling that particular thread which is running my flight mechanics solver, execute, and the sensor output will be given whenever the next scheduler is, whenever it is scheduled. So it is getting now scheduled with the time of the real time of the computer as per what I have coded in the scheduler, and that's where the RTOS plays important role. So scheduler will ensure that all the resources required are given for that task. Okay, so let me now bring this. I gave you example about looking at one aircraft, but I started with I want to fly multiple aircraft. Okay, so how do we create this simulation framework which will help me in flying multiple aircrafts in the lab? Okay, so one simple possibility is that I have one computer where I do one vehicle simulation, and I have that interfacing hardware, and this is my actual hardware, and the loop gets closed here. Okay, so I want to fly 16 aircraft. I must have such 16 setup, and of course the 16 hardware will be required because those are the actual hardware. Now, if I want to manage 16 computers and soon let's say I want to fly 30 to 50 aircraft, it will become too cumbersome for me to handle so many computers. So is there a way, can it be reduced? So one possibility is, as I said earlier, that execution is just taking 70 microseconds and I have 1 millisecond of time. So there is a lot of spare time. Can I introduce more number of simulation in that 1 millisecond? It means with one computer I will be able to do multiple simulation. Okay, so only now goes the task is, do I have an interface which can take care of so many vehicles? Okay, so that's what we do. We have one computer in which I do n vehicle simulation, and I have an interface which can take care of this n vehicle simulation, and I have actual n hardware which will be actual processor which is in the loop. Now if I want to compute more, because there will be limitation on either on the computer side or on the interface side, then I can further multiply those number of setups and increase my capacity. Another possibility could be that I have multiple vehicles, and as I told earlier, like what I need the sensor output at this interface. Okay. Now it so happens that the vehicle simulation which is created by someone, he is not ready to share the code with me, and so I cannot integrate my interface code with that simulation. But there is a provision that these vehicle states can be transmitted to some other computer using our internet. Okay? So if I have such a simulation framework, then I transmit all those states to another computer over internet and create this interface and have my hardware loop simulator. Okay? This also gives an advantage that if I have my simulation group working at different locations, okay, but I need this hardware will be only at one location. So now they can fire their vehicle simulation from different locations, but connectivity is required which should be close to real time. Okay, so that is where the key point comes. So here we use some kind of a soft real time. So typically for the internet what we do, we use TCP/IP. If you use TCP/IP, then there is a overload of acknowledgement, and if the acknowledgement doesn't come, the process here will get stuck. So instead of that, use a UDP, but send n number of data much larger than what is required. Once in a while, if you miss the packet, you are not lost much information. Okay, so that is what we do. We send data over the UDP to some other computer, which will sort out at regular time and give it to the interface, and that's where this soft real time has come into the picture. So let me skip this. This is just creating now more number of vehicles in the same framework. Okay. So just to give an idea, in our lab, what we have done, we have used a MATLAB based XPC target. They have a hard real time operating system, and we created a hardware loop simulator. But the issue was your compilation happens somewhere, it ports into another hardware, and then there's an onboard computer which comes into the loop. And if I want to increase the number of aircraft, then again the computation happens in 70 microseconds, so I can run multiple aircraft in this. So we did 4 aircraft together in one computer. But the limitation came, MATLAB does not support all the hardware which is available, it supports only limited hardware. So our maximum we could do it 4 aircraft. I had enough computational power available, but my interface was not adequate to add more aircraft. So then we thought, let's try something different where I can add more and more aircraft and I'm not dependent on proprietary softwares with respect to the MATLAB. So if I can have a software which is working on general purpose OS, because most of the drivers are available for general purpose OS. So let us look at how we did. So this is how from 4 plus 4, and we have done the simulation for 8 aircraft, which is working in real time with all the hardware which will be used in the actual flight in the lab other than the aircraft. Because the aircraft is simulated, which is in the real time. But rest all hardware is getting tested. There's a major issue why you may wonder what's the problem. There's a major issue in these aircraft which are communicating with each other. They are communicating over wireless. Okay? And there is a lot of packet loss in the wireless if you try to flood it too much. And we use very small bandwidth wireless packets. Zigbee we use because those are very lightweight, low power consuming. So they have 120 kbps, I think 100 kbps, Swarup. How much 100 kbps? 115 kbps bandwidth. And if I want to put more data, there will be a lot of clashes happening. So to resolve those problems in the lab, we can put it in the lab, communicate with each other, and what are the topology for communication, we can prove it in the lab. So let us now come to, can I expand it more using general purpose OS rather than using a real-time OS, okay? So what we had in the lab, we have general purpose OS, which is Windows or Linux, running on a PCB, on a personal computer. And there's a flight mechanics simulation called JSP Sim, which is available, well-tested flight mechanics simulation framework. And that we are executing at 1 millisecond. And we are sending sensor values at 100 Hertz and actuator position back to the flight mechanics at 100 Hertz, okay? I'll just take 5 minutes. I think I am exceeding my time, okay? I also maintain this real time. I should not bust the time, okay? So there are various ways to communicate with this autopilot board. I can have a USB interface, but USB interface is again a buffered device. It does not give me the real-time interface that. Okay, so just quickly tell you, when I do with a real-time interface, with USB interface, we are finding a lot of jitter, which is sometime going up to like, supposed to be at 10 millisecond. So most of the data is at 10 millisecond, but some data is going way beyond 10 millisecond. So we thought, why don't bring in a serial card instead of interface through the USB? And then the jitter was much less, okay? Then once we got this idea, then we thought, why not put more aircraft and try out, okay? So after that, let me skip this part. Okay, let me just briefly tell you one idea. So as I said earlier, my execution is getting over, and if it is a general purpose OS, then it is not able to schedule at the correct time where I want. It can schedule somewhere later on, but that may not be guaranteed that even it is scheduled in the next slot. Okay. So in the JSB Sim, what they are doing is they are giving a fixed sleep time after every execution. After sleep, the execution will again happen, but not sure what time it will get executed. So sometime it actually skips the whole time duration, and when it skips, what it does, it does two executions simultaneously. So it's like I'm slowing down, I run fast, again catch up. If again slowing down, I run fast, again catch up. That's the scheme they have used in their framework, okay? And that we looked at little critically. I'll just skip this part. We introduced one oscilloscope in between to give a digital pin and out whenever the execution gets over, and trying to find out, is there any really, how many times catch up run happens actually. So then we looked at it. This is the output of that digital pin going in out, high and low after every execution. So the time between one high and low is the execution time of that code. Sorry, not the execution time, the time between one step to other step in the JSP Sim, because execution time is much, much less. Okay, so when we look at it, you'll find there are spikes in this, and which is given little more in clarity here. And these spikes are nothing but those catch-up runs. So it's sleeping for some time, sleeping, and suddenly finds that it has slowed down. Then it will execute two code at the same time, two steps at the same time, and again comes back into the real-time band, and then again slows down, again catches up. So we thought, why not remove this anomaly by maybe use IRQ, or maybe finding out how much actual sleep time is required. JSP Sim is giving a fixed sleep time, and now we thought, why not use actual sleep time and give it and see what happens. And that's what we did. Let me skip this time. So this is the JSB Sim. You'll find these things are not at regular interval. Of course, when you look at the global time when I say if it is a 1 hour flight, it actually completes in 1 hour with a jitter of 1 delta t, because that's only mismatch it can have. But when we did with the variable sleep and IRQ, it's perfectly matching with my DT what I have. Still we are in the framework of general purpose OS. So what is the deficiency in general purpose OS? When I use it, my code is not actually getting executed at this thin line. It's somewhere getting executed in that band. But I have enough time for computation, because I need only 70 microsecond in that 1 millisecond. So that's where we are able to match, I won't say a hard real time, a very pseudo real time. It's not even a soft real time, it is a pseudo real time, which is getting close to real time and able to give the performance what we need as a real time operating system. So once we achieved this, then we thought, why not? Your ambitions keeps increasing. So now we started looking at 16 aircraft in the loop. So there's only one PC which is running 15 flight mechanics simulation. Okay? And then there are 16 of those processors, real processor, 16 of those real communication links, and we tested in the lab and made a flight simulator where we can execute 16 aircraft together. And as I said earlier, this all goes, the basic requirement is from the computer science, which is related to the operating system. And that's how I'm linking it to the CSI 2020. Okay? Yeah, if you have any other questions, this is about the 16 aircraft. This is how my CPU usage increases when I add the aircraft and those terms. So right now, again, it got limited by the serial port what we are using. It's only a 16 port serial card. So if I have higher port serial card, I will be able to maybe increasing. But the idea is like, can I have more simulations on one computer and using the actual hardware? That's the idea what we have. This work was supported by, there was a national program on micro aerial vehicles. So we got funding for developing hardware and loop simulator, which are under AR&DB, Aeronautic Research and Development Board, Department of Science and Tech. So this is what, if you have any questions, I'll quickly take it up. I won't take much time. So questions will be mainly asked.
All right, do we have room for questions?
A question here, on your left. Not entirely my domain, but may I ask, wouldn't GPU framework be an option for the same?
GPU based?
Yeah.
See, ultimately what we are looking at is, can I complete my flight mechanics simulation in that delta T? Okay, if the GPU is able to do it, there's no problem. In fact, we are looking at a solution which are going to the embedded controller, like BeagleBone or RPi, because then the size will reduce. I can take it to the field and test it. I don't need a personal computer. So that's not the limitation. Limitation is, as long as I can compute my flight mechanics simulation in the time step which is used for my propagating the flight mechanics equation. That's the limitation.
Do we have some more questions? Anybody? All right. Thank you so much, sir. Would like you to be on stage with us. Ladies and gentlemen, can you please put your hands together for Professor Hemendra Arya, Department of Aerospace Engineering, IIT Bombay. Well, I'd like to invite on stage Dr. Gupta, Honorary Head CSI Mumbai. Ladies and gentlemen, can we also put our hands together for Dr. Gupta? Dr. Gupta is now going to felicitate Professor Hemendra Arya with a token of appreciation.